Photosynthesis is the second most important chemical reaction of all nature. Both animals and plants rely on the energy it provides.
Today, we will get a close-up view of the inner workings of photosynthesis. The first part of photosynthesis are the light-dependent reactions that occur on the electron transport chain. It starts with sunlight being absorbed by photosystem II, a complex protein. Photosystem II then transfers its energy into an electron.
This energized electron is passed down the ETC by the complex proteins called the electron carriers, but some of its energy is taken away. Enzymes on the thylakoid membrane break water molecules into hydrogen ions, oxygen atoms, and energized electrons.
The energized electrons replace the original energized electron and continue its journey. Meanwhile, the oxygen is released into the atmosphere, allowing us human beings to live. After this, energy from the original electron is used to transfer H+ ions from the stroma into the thylakoid space. We'll get back to these later. Finally, the electron makes it to photosystem I. The electron is tired from its journey, so it is re-energized by the energy photosystem I got from the sunlight. At long last, the energized electron meets NADP+, a molecule akin to an empty bus. The two combine and NADPH is created. Now the bus is full of chemical energy. In order for ATP to be created, H+ ions must make it back through the membrane, but they can't do so naturally. So a protein, called ATP synthase, helps it across. As H+ ions pass through ATP synthase, it rotates. ADP and a phosphate group join to create ATP. As the process repeats itself, more and more H+ ions are pumped into the inner thylakoid membrane, giving the inside a positive charge and the outside a negative charge, similar to a battery. This interaction provides the energy to make mighty ATP. This amazing system, tempered by millions of years of evolution, creates both NADPH and ATP at minimal costs. It is truly amazing. NADPH and ATP may store a ton of chemical energy, but they are not stable enough to hold on to it for long. This is where the second part of photosynthesis comes in, the Calvin cycle. It starts with 6 carbon dioxide molecules entering the cycle and combining with 6 5-carbon molecules. This creates 12 3-carbon molecules, which are converted into higher energy forms by the electrons from NADPH. Two of the 12 3-carbon molecules are removed from the cycle and are used to produce compounds such as sugars, lipids, and amino acids. The remaining 3-carbon molecules are converted into 6 5-carbon molecules and used in the next cycle. Congratulations, you know the basics about photosynthesis. Let's hear what others have to say about this.
Hey, Ryan Broad here. Stick with people on the streets at CO. This is Brian Smalley, one of them. How's it going, Brian?
It's going good.
So, are you aware that the photosynthesis is split into 2 parts? What can you name the 2?
Light dependent and light independent reaction.
Where does the light independent reactions occur?
In the chloroplast.
Very true. Thank you, Brian. It's good to hear you. I hope you have a great day.
Okay.
Hey, what's up, boys? Ryan Berard here with John Eaton. Unfortunately, we had to stop him while he was in the middle of eating his lunch. Am I right, John?
No, you're wrong.
Well, here's a question. Of photosynthesis, what is your favorite part?
Part number 1, 2, and 3.
Would you name those parts for me, please?
Yes. Green part number 1, purple part number 2, blue part number 3.
He is referring to photosystem 2, the transport proteins, and photosystem 1, which are 3 key elements in light-dependent reactions. Thank you very much, John. Hope you have a great lunch.
You too.
Hi, it's me, Ryan again. I'm still on Studio, this time with Zach Taylor, my BFF.
Hi.
So, Zach, are you Jewish?
No,
Are you excited for Christmas?
not really.
That's a shame. Are you aware that photosynthesis is the second most important chemical reaction in all of nature?
Yes.
Good to know. Have a good day. Thank you.
Bye.
He said bye. Hi, I'm Ryan Berard here on the streets at TO with resident superstar Jay Lesney Drake. What's going on, Jay?
Not much. How about you, Ryan?
It's great. How are you excited for the break?
Yes, I am.
So, on a scale of 1 to 10, how would you evaluate the importance of photosynthesis?
10 out of 10, Ryan.
Why?
Because it gives us energy.
I suppose in a way it does, through plant eating.
Bye, Ryan.
Bye. Hear about the race between the lettuce and the tomato? The lettuce was ahead. The lettuce was ahead, and the tomato was trying to catch up.
Good one, Ryan.
Okay, tell me. Now, it would seem that we are at journey's end, but that is not the case. Enzymes on the thylakoid membrane break water molecules down oxygen atoms.
One.
Matthew, I need a tennis ball. I start with the tennis ball. Give me the tennis
All
ball.
right, Ryan, go.
Okay, restart.
What?
You have to say something first.
Hydrogen ions. The oxygen is released. Sorry.